What up, athletes? Whoop, whoop. All right. Wow. Gotta move that down out of the way. Boom. Move this back up. Okay, peeps. Let's talk about this. This is 3.3 linearity and continuity of graphs. Your learning target is I will identify linear and nonlinear functions and continuous and discrete functions. Don't forget, as you're working through this, make sure you write down learning target. Make sure you pause in between because I'm just going to boot, scoot, boogie. And here we go. All right, take a minute. Determine whether each function is linear or nonlinear. Is it going up in a line or is it not? All right, I'm assuming you paused it. Let's look at this. All right, so each time we notice that the width is growing by 20. All right, that's plus 20 each time. Plus 20 plus the width. The width of the lot is growing by 20 each time, okay? Down here, let's look at it. What does it grow by here? It grows by, what is that, 2,200? And then right here, what does it grow by? It grows by 2,600. Okay, is that growing at the same rate? Remember, to be linear, it has to grow at the same rate. So, no, this isn't. And then right here, we see it grows by 3,000. So, no, this is not linear, no. Let's look down here. We see it's going to be plus 1, plus 1, plus 1. I know I kind of put these tables tight together, right? It's hard. And down here, it's just 8. It's plus 0, plus 0, plus 0, plus 0. So here's what I would say. I would call this linear because it's the same rate, right? These are changing the same. These are changed by 1 each time. These are changing by 0 each time. So this is linear. It's going to be a line. All right. Let's see. This one is growing by what? 1.25? And right here, 1.25, yeah. And 1.25, okay, so that's the same. And right here, we grow by 0.5, 0.5, 0.5. Yep, that's the same. Since it's the same rate for both, this is linear. So this last one right here, let's see. It goes up by 0.5. Okay, it goes up by 1.8. Goes up by, what was that, 0.5 again? And 0.5, and then it goes up by a lot. So this is growing at a different rate. Let's see what it does down here. So this goes up by 0.6. This goes up by 1.5. This goes up by 0. And this goes up by 0.2. Now I want to focus on the 0.5s. When this grew by, it could be that this grew by 1.8, this grew by 1.5, so maybe that's comparable to this growing by 0.5, this growing by 0.6. But notice this, if this grew by 0.5, this grew by 0.6, this grew by more than the top. But this bottom one grew by less than the top, so already we can tell the rates are different. But then if I look at this 0.5, it grew by 0, and this 0.5 grew by 0.2, so the 0.5s are growing by different rates. So I would say this is not linear. Okay, awesome. All right, got some vocab to look at, guys. Let's take a look at it. There we go. Discrete function is a function in which the points on the graphs are not connected, so you don't connect the dots on the discrete function. We'll talk about that. Continuous function is where you do connect the dots. A linear function is a function with a graph that's a line, and a nonlinear function is a function in which a set of points cannot all lie on the same line, unless, in other words, it's like the graph. It's not a line. It is a curve, or maybe it's just jaggedy, but it is not a line. Or there's other versions of that as well. Okay, there we go. Pause this because you're going to need it, and we're going to get right back on with the lesson. So, I'm going to talk about being discrete, continuous, or neither. Let's look at discrete. And it's going to feel like you're saying the same thing over and over again, which you are to some extent. So discrete is if we look at the domain, remember domain is what? It's x and range is y. So if I look at a discrete graph, the domain is this just a set of individual values. The example we give you right here, let's look at the various x values and put them in the set. Let's see, there's, looks like 2.5, or no, that would be 3. That's in between 2 and 4. These go up by 2 each time. So that would be 3, 4 on the x, and then that looks like 7 on the x. So just 3, 4, and 7 is all the domain here. If we look at the y values, again, each one's going up by 2. That would be 3, 4, and 5. So again, the range is just going to be another set of individual values. There's no pattern to how these are growing necessarily. There could be, but there's not necessarily. And this is just the set of, what is that? Again, 3, 4, 5. Now that doesn't mean we can't write them as an ordered pair. Like this would be, what, 3, 3. This would be 4, 4. This would be 5, 7. Or I'm sorry, 7, 5. Okay? Now let's look at a continuous graph. A continuous graph, oh, and I forgot to say, points are not connected. So points not connected. Notice we didn't connect the points. Over here, let's look at the continuous graph. Points are connected as a linear curve. And again, the domain, now look, this arrow's going up forever, it's forever going a little bit to the right, forever going a little bit to the left. So in the x values, the domain is going to be all real numbers x. In other words, any x number, any x value. Now the range. Notice the range, in this case, it doesn't go below -5. So the range for this one would actually be y is greater than or equal to -5. But what we would say in general, it's going to be one interval. Of real numbers y. In other words, it's going to be an interval. It's not going to be all like the x is going to be. It's going to be an interval here, okay? Now, we're going to talk about neither. Notice how we have sections where it's continuous, and then we have a section where it's discrete, right? Where these two aren't connected. That's called a neither. When you have elements of both, it's neither. And what we say is some points are connected and some points not connected. So it has elements of both. And the domain is going to vary. It depends. Sometimes you're going to have all x, sometimes you're going to have just partials of x. In the same way, the y varies, because sometimes you're going to have all y, sometimes you're going to have parts of y in intervals. Again, it has elements of both of these. Okay? All right, pause this, write it down as needed. Let's go.